Okay, here we have a tangent line defined. Might be helpful just to take a look and see what the sketch of this graph might look like. So I'm going to just throw that in over here. Here we have a function x cubed minus x, so there is no constant. It wants to go through 0. It wants to be going down through 0, as we can see by the negative x, with the slope of negative 1 as it goes through. But ultimately, it wants to act like a positive cubic. So it's coming back up again. It's going down to the left. And somewhere on here, we have a point 2, 6. And we are looking for our tangent line at that point. Something along the line of that equation of that tangent line. So until we have a quicker method for coming up with these derivatives, we're going to go ahead and go through our whole limit process. The limit as h approaches 0 of f of x plus h minus f of x all on h. And f is a factor that takes things and puts them right here and right there. I want to put x plus h, for starters, into those two positions. So I get x plus h gets cubed minus all of x plus h. That is f of x plus h minus f of x. F of x is explicitly given as x cubed minus x. However, I'm bringing that in as a binomial. I better subtract the whole binomial. All on h. So here I've got some foiling to do, and I'm going to use our friend Pascal to help us with this. Third row of Pascal's triangle, 1, 3, 3, 1. So I get 1 x cubed plus 3 x squared h's plus 3 xh squareds plus 1 h cubed. That's our superfoil of x plus h cubed. I'm going to distribute the negative or the minus x minus h. I'm going to distribute the next minus x cubed plus x all on h. If we did that right, all of our non-h terms should cancel. And I get an x cubed minus an x cubed. I get a minus x plus an x. And everything else has an h term in it, which I can reduce with this h. So I'm left trying to find the limit as h approaches 0 still of reduce this guy by h, 3x squared, reduce this guy by h plus 3x, a single h, reduce this guy by h plus h squared, reduce this guy by h minus 1. And now direct substitution of 0. 0 goes in for h, 0 goes in for h, and I get 3x squared minus 1. That is our slope formula or our derivative of f. So we would notate that as f prime x equals 3x squared minus 1, which don't let it get lost on you that that is our slope formula. That says you tell me an x coordinate on the graph, I'll put it here and I'll tell you the slope. But we are interested in this x coordinate right here. So the slope we're going to use is just f prime of x, which is 3 times 2 squared minus 1, or 11. So I need a slope of 11. I need to pass through the point 2, 6. So the equation of my line is y minus the y coordinate 6 equals slope 11 times x minus the x coordinate 2. And that's a skill that we're going to be very, very good on.